In today's problem, we are going to discuss the mechanics of a crane member. Let me just give you the problem description, and here we go. So there is this member AB that you can see. It has been kept at a particular angle of 60 degrees. It has been maintained in this position with the help of three cables, that is AC, AD and AE. We have been given in the question that the tension along this cable AC is equal to 8 kilonewtons. Secondly, tension along this cable AD is equal to 10.4 kilonewton. What we really need to work out is the tension in the third cable, that is AE, such that, or in such a fashion that the resultant of these three forces is along this direction AB, or is at an angle of 60 degrees with the horizontal. So this is a very weird condition which you have to stick to, right? Based on this condition of the resultant, you have to find this TAE and also the value of R. How do you plan, or what is your approach going to be for such a question? This is something that we'll be discussing in today's session. So good evening, friends. This is Patnaik, your friend and tutor. And as I've said, we'll be discussing two techniques, one graphical while the other is analytical. In the first 5 minutes, let me discuss this graphical technique. This is going to be fun. And if you have a pencil, a scale and a protractor, we are good to go. Here we go. For applying the graphical technique, please note that you have to take a scale. Let's say 1 kilonewton is equal to a length of 1 centimeter. As I've said, if there are two forces in the picture, one sec. How many? So if there are two forces in the picture, the options that you have is the triangle law of force addition, or you can also go for the parallelogram law. I mean, these two laws are going to help you get the resultant's magnitude and direction both. However, if there are more than two forces, in this case, you have as many as three forces, out of which one is unknown. In such cases, you have to go for polygon law of vector addition. Okay, that is graphically, right? So how many forces do we have? Sir, we have three forces. Now these three forces will get you one resultant. Okay, so the polygon that you will have is a four-sided geometry, right? The polygon will be of four sides. These three sides by the three tension in the three cables, and the fourth side will be taken in opposite order. That will be your resultant. Please note this. How do we begin? Sir, we begin from here. Let me just start. 8 kilonewton, that is equal to 8 centimeter based on this scale. 8 centimeter. Let me write this as 8 cm. Let me highlight it. Done. Now what to do? Now, sir, we are going to pick this blue colored vector from its tail, and we are going to put this on the head of this green vector like this. And this, by the way, is 10.4 centimeters. All of this can be managed with the help of a scale and a protractor. By the way, please note that this is positive x-axis. The angle measured is always with respect to the positive x-axis. If it is measured in this fashion, it is positive. That is, when you are measuring it anti-clockwise, it is positive. However, if you are measuring it in this fashion, this is negative measurement. Please note this. So far, so good. So how much would this angle be? Sir, it is going to be equal to 180 plus 25. Okay, this is 25. This much is 180. Done. Very easy. So with the help of a protractor, make an angle of 205 degrees. This is 205 degrees. And then you can draw this line of 10.4 centimeters. But what now? How do you approach it now? Now, sir, these are the two forces. There is one more force remaining, which has been represented by this color purple, right? So pick it up with respect to its tail and keep it over here. We don't know what the magnitude is. However, we know that it makes an angle of 45 degrees with the horizontal. And if you observe carefully, this angle over here is 45, right? So at an angle of 45 degree clockwise, clock or anti-clock, you need to note this. Okay, here, this is 45 degrees. Done. Resultant's magnitude is not known to us. Quite obvious. However, the angle it makes with the horizontal is known. Here the angle made is 60 degrees. So if you watch, the angle made over here is going to be equal to 60. If this is 60, then this angle over here is going to be equal to 120 degrees. So from at this very point, okay, just draw a line, right? Either you can go for this angle as 60 degrees, or you can go for this angle as 120 degrees. Both of them intersect at a particular point, and this point, well, let me now erase. This is your TAE, this is your resultant. If you watch, these three are following a particular order, and this has been taken in the opposite order. Okay, so that is your resultant. However, now what you need to do is you need to keep your ruler over here, the physical ruler, this I'm talking about. Keep your scale along this line R, do the measurement. I'm sure you are going to get the value as very close to 16 centimeters. Secondly, do the measurement for TAE. It is going to be equal to 13.5 or 13.4 centimeters. If you do the conversion, you know very well that 1 centimeter is equivalent to 1 kilonewton, and hence 13.4 centimeter will be equal to 13.4 kilonewtons, and 16 centimeter will be equal to 16 kilonewtons. So this completes our problem following the graphical technique. If you want to do this on AutoCAD, you surely can. Do you want to see this? Let me show this to you. You can do this on AutoCAD also. And let me make some space. Yeah, right, this done. 8 centimeters, 10.4 centimeter. And as far as these two are concerned, let me show this to you. And by the way, please check if you have this in centimeters or not. I've already fixed it. Okay, now this TAE happens to be at an angle of 45 degrees. Yeah, 45 degrees clockwise, right? So what we'll do is, let me use the line command. At the rate, let's say a line of 30 millimeters long, angle will be minus 45 cents. That is clockwise, this way. This angle clockwise measured minus 45. We don't know what the length is. Resultant's head will be here and tail will be somewhere here. No. Resultant's tail will be here and head will be somewhere here. The important thing is that the resultant is going to make an angle of 60 degrees with the horizontal, right? 60 degrees. So please watch, 60 degrees here, 60 degrees. So in this way, clockwise with the positive x-axis, it is 120 degrees. So watch again. From here, let's say randomly we draw a line of 40 millimeters, angle will be minus 120, right? This is how you need to draw, parallel to R, and this line is parallel to TAE. Okay, follow the instructions. Now let me chip off this portion. And what do we need, sir? We need the length of these two lines, right? Again, let me use dim aligned, enter 15.97. Okay, as I've said, this is your resultant. Let me show this to you. 15.97, that is the value of R. And here 13.35, that is the value of tension in the cable AE. So this concludes our first approach, which was the graphical technique. In the second technique, what we'll do is we are going to use the statistical method, or using statics. For that, what we need to do is we need to resolve these forces into their components. So follow this. This is going to be fun. 8 kilonewton force. It is already in the along the x-axis. Don't worry. 10.4 can be resolved into two components. One component is along this direction, 10.4 cos 25, while the other component is along this direction, 10.4 sin 25. If you watch, this R also can be resolved into components. This R will have two components. One will be over here, and let me mark. This is, by the way, 60 degrees. Okay, so one component R cos 60, while the other component R sine 60, right? And the third one, this TAE. TAE again, if you watch, can be resolved into X and Y. This angle over here is 45 degrees. So this over here is going to be TAE cos 45, and in this direction the component is TAE sine 45. The next thing to do is the sign convention. Please note that any force in the X direction is positive, above is positive, leftwards is negative, downwards is negative. By the way, we here the net, the collective effort of these forces is to make a resultant, right? There are cases where you'll see in the chapter of equilibrium in 2D or in 3D, the net force will be equal to 0. Okay, whenever you are studying an object which is in equilibrium, there the net force or the resultant happens to be 0. Okay, take a look now. Here we are just interested in this very point A. Okay, all the analysis is being done because of all of these forces which are acting on the screen. That means all of these forces are coplanar. Secondly, these forces are passing through one single point. That means they're concurrent. So we are dealing with concurrent coplanar forces. If you watch, 8 kilonewton negative, minus 10.4, and this R cos 60 is also negative. Any other force? This is positive. Let me write them down. Done. Simplify it. Done. Secondly, what we can do is we can take this as this is negative, this is negative, this is negative. Any other force? No. R sine 60 is also negative. Okay, and then these two forces remain. Let me write them. Wonderful. Arrange them. Now these are the two equations that you have. You can make use of a calculator and solve them. Okay, let me just show this to you. Shift 9 3 equal to go to mode. For equation hit 5. Then this is the first format. What is the value of A? AR B, AX plus BY is equal to C. That is the format. Value of A is cos 60. Cos 60. Enter. Cos 45. Cos 45. Enter. 17.43. 17.43. Enter. Then you have sine 60. Sine 60. Enter. Then you have minus sine 45. Minus sine 45. Enter. Then you have 4.4. 4.4. Enter. Enter again. And you can see 15.98. That is your first result. And then you have another result as let me just show this to you. 15.98 and 13.35. These are the two results which we have got. Right? So this is how you can attempt problems on problems where you are involved in the calculation of more than two forces. Okay, here there were three forces and the resultant had to be along this direction of AB, right? A wonderful problem, in fact. So guys, that was all from my side. If you are this way through the video, I would strongly urge you to like it and also share it with all your classmates, and also subscribe to my channel. This is Patnaik signing off. Take care and have a nice day. Thank you.